So the first topic that we're going to cover in some detail are network models. And so let me bring up there's the network model page. And the format that we were going to follow here was was that, and I'm laughing because I'm accidentally hiding the chat session that we were having on the core page, and I apologize for that. So the format we were going to use here was I was going to give you some background justification from the impacts and the business drivers, and then Greg was going to walk through the design aspects to it. Network's one of those interesting ones to me because we've actually been doing significant network refactoring all along. And what we reached was a point where the changes that we needed to make to network would involve impacts to the networking models, the operating system models, the chef libraries and recipes. So all 5 of these items are interconnected. The good news about the networking pieces is a lot of them were already staged in the code and we're ready to go. The idea here is that we got some very clear feedback that networking in Crowbar was powerful, but confusing. The thing that people really had a lot of trouble with, understand this, was modifying the network JSON file and then having to make all those changes up front in advance. While not all the changes had to be made up front, they were always edited in JSON. It wasn't clear which things could be changed up front and which things couldn't. And so the solution for this is to actually model this as part of the database so that we can create an overall network framework. And this is going to allow us to make the things that are dynamic within Crowbar networking, where we have a lot of power and capabilities and really bring a lot of value into the configuration orchestration. We are going to make those things API, UI, and command line driven so that people can build their networks dynamically on the fly, or even more importantly, that their bar clamps can build their networks dynamically and on the fly. And consequently, this should really help people address how they provision networks using Crowbar and how flexible and dynamic those networks can be. So, Greg, do you want to talk about that some more?
Sure. So, from our perspective, one of the biggest complaints that we've gotten from our own internal field deployments, as well as some of the list and public deployments, have been around the fact that once you can only change networking at the beginning and have to reinstall after if you need to make changes to networking, and that's been really painful, and we understand that. We haven't necessarily had all the tools in place to make that better. With the introduction of the database layer, we now can start doing better jobs of modeling and keeping track of where addresses are. We get better transactions so that we can keep track of states as we're going. So all of this leads to kind of a more software-driven networking, if you like that term or not. The idea is that we'll create models within the network bar clamp for things like VLANs and networks and bonds and even bridges, though we may look at some technology has been proposed to try and move off of bridges as well, but we'll probably start with bridges in the model as well, so that we can create changes to the network bar clamp that let us represent those relationships outside of just the current one big network stanza in the network JSON file. This leads to 2 kind of big sets of changes that we're going to look at. One is the actual underlying models. So we're starting to work on defining what those models look like. And then the second is to treat networking more as a API that you can do your basic CRUD operations on, as well as some additional operations to add and remove nodes from those networks and stuff like that. The goal being that Crowbar out of the box will have its admin network. And that will be the only network that Crowbar really knows about. And as we go forward, you can do edits to that network, and Crowbar will attempt to roll that out in a safe way. The admin network, admittedly, is probably our trickiest one, is because it tends to be our main communication path between the actual nodes and the Crowbar admin server. With all that said, we want to be able to enable the user to add networks as needed, to let bar clamps reuse networks, or let bar clamps even take control of adding networks themselves. So one of the thoughts would be like, Swift needs a storage network. The idea would be to allow the Swift bar clamp to manage that storage specific network. Those kind of things are where we're trying to go to give better control over bringing up and tearing down networks on the fly, so that the reinstallation problem isn't about blocking or barrier to entry. Okay. Let's see. What else to say? Yeah, I mean, that's kind of just the straightforwardness of it. The goal is to also try and simplify some of the conduit device mapping and allow for individual overrides. We've realized that some of the node work around bringing up nodes and accessing nodes and controlling them is somewhat specific. And we're beginning to realize that there are use cases that you want to be able to say this node deviates from our normal networking policies or default stanzas, so you apply this. It already exists today, but we need to try and do a better job of calling that out and making it configurable. So those kind of options are where we're headed. We're still in the early stage of this. We're starting to define the models so that we can make sure we've kind of got a breadth of what we need to do. And then some of this changes around the networking bar clamp that are now in the trunk cover some of the changes already, at least from rolling them out. They'll still need to be converted on the bar clamp side to drive what we actually want to configure. Okay. I guess that's kind of that feature and where we're going with it.
Why don't you also describe some of the changes that Victor's been putting in the code to make network configuration so that they can know what to expect with that, and describe how that's going.
So in some regards, if you've looked at the network bar clamp, there's kind of there's lots of pieces, but it's split kind of into two parts right now. One is on the bar clamp side for storing information about what the networks and nodes should look like. And then there's the actual recipes that drive what the node becomes. The recipes Victor's reworked, and that's in trunk right now, to not necessarily rely on parsing the OS-specific configuration files and setting up networking by changing the Linux-specific items and then setting the network-specific pieces for if the node reboots and stuff outside of that. And the idea is that the network bar clamp's been changing so that we can turn networks on and off without necessarily forcing the node to have to go through a bunch of restart gyrations and all sorts of other stuff. So a lot of that stuff is now gleaned directly from the underlying Linux kernel and set through that. This is particularly important for bonding and some of the other cases where some of the OS configurations aren't necessarily easy to unify. All of that stuff is currently in the trunk and available for testing. What isn't there is the modeling part on top. So right now it does a great job of being able to say, I want to set this network, I want to build these layers and stacks, but it's not driven right now, excuse me, from the bar clamp. And the goal is to move a lot of that logic up into the bar clamp so that it can make the decisions and then push that to the recipes to instantiate. We're trying to get that code on the OS-specific side somewhat more genericized, so the part that is OS-specific is more around the actual writing out of the config files to handle reboot and restart kind of issues, opposed to the actual changing and on-the-fly parts.
And one of the things to point out for this is that in the models, we will be extending the model to switches and building more of the network topology. So One of the things that we found that we wanted when we started the whole project was to be able to make application decisions based on network topology so that you could identify fault and failure zones. That is still an important goal for us. Having network modeling that includes the switches. Right now, when we present switches, they're really from the node's perspective. They're not their own item, is part of what this network modeling will accommodate. And then you should be able to leverage that in your bar clamps so that you can choose, you can move application deployments across switches so that you have redundancy from that perspective. That's another component for this.
Yeah, this is that part, that kind of minimal view of a switch we gather currently through our LODP media frame discovery process. And the goal is to make that more of a first-class data element for the bar clamps to make decisions off of.
While we're in this topic, I would also have you just spend a second talking about the Nova changes that we're talking about making with OVS.
So that was, I kind of alluded to that. That's the bridging aspect. We may, or I don't think we've necessarily
we haven't
finalized that. There are those in the community on the OpenStack side that have been looking at using OVS kind of internal, even without Quantum, to get around using Linux bridges, which work but have some quirkiness to them, especially if you're trying to do bonding or redundancy. They kind of get in the way. And so some community members have looked at using the Open vSwitch or virtual switch pieces and running those just on the node as the bridging component so that they can then hook interfaces on top of and underneath that virtual switch. One of the things that we've considered is that seems like actually a pretty good idea for dealing with a lot of or to get around a lot of the bridging headache that we go through today. Like we right now, if we want to set up bonding, you have to use you have to use mode 5, which turns into server side kind of failover based, and it's not even load balanced. It's more of an active passive bond. And that's fine for potential just, making sure you have connectivity, but it doesn't help with your bandwidth concerns.
Right.
With an OVS, you could potentially, and that's because of bug in the bridges. We could move to an OVS and actually use a better bridged or bonding setup with the OVS on top of that to hide some of that stuff. So it's potentially very powerful, could be very useful. In some regards, the networking bar clamp changes are to enable that as a follow-on feature if we think it's a good idea. Right. I don't sound quite as excited about it because I think it's still got some stuff to work out, and it could be very useful. I don't necessarily consider it directly core to the Crowbar 2.0 features, but it represents kind of something that could be enabled as we go forward.
So I'm going to wrap up the networking piece with what will probably become a mantra for this design brief. Our goal here is not to accomplish everything that we just laid out. It is to enable everything that we just laid out. So our philosophy from the very start with Crowbar was incremental architecture, not to try and lock us into a lot of pieces. So as you see the networking models emerge, it is our goal to not over-specify them and to not provide every possible use case and everything in the models. We will add the use cases as we go, and therefore the models themselves should be expanding as we go. So that means that you will see migrations in Rails that allow us to expand the network models as we accommodate more and more of these use cases. So please understand that. One of the things that allows us to do is take feedback from you, from the community, about how these network models should be built. So rather than locking in a whole bunch of properties and methods and data attributes around the network models, we're going to try and leave them flexible and add them as we go. Rails is especially suited for this, and we find that it lets us accommodate your feedback and use cases and things like that. So That is a general thing that we want to accomplish in the refactor. We want to minimize the refactor, get Crowbar working in its core form again as fast as we possibly can, return to a shippable product. And so expect that you'll see a lot of things we're laying out as potentials here will not surface in Crowbar 2 refactor. We're going to leave everything as skeletal as we feel like is practical to accomplish basically OpenStack fulsome shipping at the release candidate. Okay, with that, excellent. I love Etherpad. This is excellent. We are shifting to another Etherpad.